So in this lecture, we are going to look at the important reactions of formic acid, which is also known as the methanoic acid. Now, what is the formula for methanoic acid? It's something like this. Now, you discover that the methanoic acid has something in similar with the aldehydes. Now, the aldehydes have this C double bond OH, and because of the presence of this group here in aldehyde has the capacity of acting as a reducing agent. And if you also look at, okay, this is not methanoic acid, this is methanol. Methanoic acid is something like this. If you also look at methanoic acid, you agree with me that they also have a similar functional group. Hence, formic acid can act as a reducing agent. Now, it also reduces Ferlin solution and toluene solution. If you can remember, we said toluene solution is silver mirror test, while the Ferlin is the one that has the copper as part of its reagent. Alright, so it means we can check for the presence of formic acid with what? Ferlin solution and toluene reagent. Is that okay? So if we have the reaction, this is it, HCOO negative plus 2 molecules of cupric ion plus 5 OH negative. This will give us to reduce, and then you have copper 2 oxide plus CO3 2 minus plus H2O. You can just memorize all this. Alright, now which reagent is this? You agree with me that this reagent here is Ferlin's reagent. Alright, because I told you that Ferlin has copper as part of its constituent. Why, in a situation where you have this equation OO negative plus Ag2 plus 3OH negative to give us 2 silver plus CO3 2 minus plus H2O. Both reactions are almost the same, just that you discover that this stuff here was reduced. Copper 2 ion was reduced to what? Copper 1. If you calculate the valency of what you have here, you are looking for that of copper, so you have 2 times copper is equals to, or many of you still know how to calculate valency. Oxygen is minus 2, should be equal to 0. So 2 copper will be equals to, when oxygen cross to the other side, minus 2 cross to the other side becomes 2. Divide both sides by 2. So the oxidation state of copper here is plus 1. So the oxidation state here is plus 1, while the oxidation state here is plus 2. So you discover that copper has been reduced from plus 1 to plus 2 oxidation states. And what reduced copper from plus 1 to plus 2 oxidation state? Of course, it is the methanoic acid or formic acid. Is that okay? That's why we say it can act as a reducing reagent, because it reduces Ferlin solution and what? Toluene reagent. Now this is for Ferlin's solution. Now if you now come to Toluene's reagent, you discover that silver here has an oxidation state of what? Plus 2. But if you come here, if something is just standing on its own in chemistry, when an element is standing on its own with no charge on top, we say the oxidation state is 0. So you see that it reduces silver, which is what? Toluene's reagent. Toluene's reagent from plus 2 oxidation state to plus 0 oxidation state. Of course, these are other members of the reaction product. Do you understand now? So that is how it actually reacts with some other compound. Now, salt formation. You also discover that okay, we are actually going to look at this later. Alright, salt formation. Now, because it is an acid, from all what we have learned, every other thing we are going to be learning here is based on what we have done before, but we are just using formic acid as an example. Now, from what we have learned before, formic acid is an acid, so it has a tendency of reacting with a base like sodium hydroxide. When it reacts with a base like sodium hydroxide, it's going to displace this hydrogen. All what is an acid will do is to remove this hydrogen from here. So it displaces this hydrogen, and then the sodium will attach itself, all right, which is sodium formate. Of course, this is positive charge, this is negative, plus water, which is H2O. So this here is sodium formate, is the product that is formed. Now it can also react with what? With hydrogen carbonate, which is also a base. So you have O and then plus what? Sodium hydrogen triazocarbonate. Of course, from what we said that this group here will leave, sodium will actually what? Come and attach here, and it will also form sodium formate plus what? Now this one will form the triazocarbonate, is that okay, or carbonic acid, which will now break into CO2 plus what? Water. Is that okay? To break into CO2 and water. So this one also form sodium formate. Sodium formate. And then you have CO2, which will be in the form of what? Gas that you can see. And this CO2, you can test it with lime water because it will turn lime water milky. All right. Now, this is a characteristics test for what? All carboxylic acid. So if you want to actually look for the identity or identify carboxylic acid, all you need to do is to react there with what? The triazocarbonate, because you are going to emit this gas CO2, which if you pass it through lime water is going to turn lime water milky. Is that okay? So if they say test for, or write a test that will distinguish carboxylic acid, what do you think that test will be? It will be reacting the carboxylic acid with sodium hydrogen triazocarbonate. Do you understand the concept? Exactly. When you do this, it's now going to form this CO2. Like I told you, this CO2, when you pass it through lime water, it's going to turn lime water what? Milky. Is that okay? So that is one of the reactions of the formic acid. Now, another reaction is esterification. What did I tell you about esterification? I said esterification is the reaction of carboxylic acid with alcohol, right? So if we react it with an alcohol like this, now this one does not require a catalyst. Remember that for esterification reaction, it often requires either HCl or H2SO4. So it does not require a catalyst. Now, at the end of the day, what do you think? Water will be what? Emitted. A molecule of water will be emitted. So it's going to form an ester. That is the process of esterification, when acid react with alcohol to form ester plus H2O. Now this reaction is reversible because once you put this water back into this thing, it's going to give us the carboxylic acid. In this case is formic acid, and here is what? Alcohol. So by now you should have known that esterification is a reaction between an acid and alcohol to form an ester. Is that okay? So that is one of the reactions of formic acid. Let's look at another one. It reacts with PCl5. Now whenever you see this reagent here, PCl5, what does it tell you? It tells you that chlorine will be added and then OH will be removed. You should know this thing. Whenever you see PCl5, whenever you see SO thionyl chloride, whenever you see PCl3, know that chlorine is substituted for what? For OH. Is that okay? Whenever you see PCl5, PCl3, SOCl2, note that chlorine is substituting for what? OH. You should know that. Is that okay? So in this case now, if you react formic acid with PCl5, now this is going to give us HCOOCl. That means yeah, no, it's not going to give us, it's going to give us HCOCl plus POCl3 plus HCl. If you count, how many chlorine are here? 5. This 1, 2, 5. How many phosphorus? 1, 1. How many oxygens are here? 2 are here, 2. How many carbon? 1, 1. How many hydrogen? 1, 2, and then 1, 2. It's complete like this. So this is the right thing you are supposed to write. If you want to bring it out, you write it as C double bond O Cl, which is formyl chloride. This formyl chloride is very, very unstable, can decompose. All right, this formyl chloride, you should take note of it. It's very, very important. All right, formyl chloride. Is that okay? So that is one of the ways of preparing this compound, of reacting this compound. Now, action of heat. Now, whenever you see heat act on carboxylic acid, especially the formic acid, is going to decompose it to give us carbon dioxide and hydrogen. Is that okay? So we are going to have something like this, HCOOH, passing it through heat. All right, and pressure is going to break this down into CO2 and hydrogen gas. All right, now how about reaction with sulfuric acid? Same thing that happened to heat is what sulfuric acid will do. Sulfuric acid is H2SO4. All right, plus heat. It's also going to break this down, but it's not going to form CO2 and H2, but rather it's going to form CO and H2O. CO plus what? H2O. All right. Now let's talk about the sodium salt of formic acid. The sodium, the salt of formate. The salt is when the hydrogen has been replaced by any of the metal, like silver. What we mean is, formic acid is something like this. So when this hydrogen here has been replaced by any of the metal, let's say plus metal, the metal can be sodium, can be calcium, it can be silver. You form the sodium salt of the formic acid, which is also called sodium. You form the metal salt. That particular metal, if it is sodium, it becomes sodium salt. If it's calcium, it becomes calcium salt. If it is silver, it becomes silver salt. So sodium formate is heated to about 360 degrees, decomposed to give sodium oxalate and hydrogen. Sodium oxalate on treatment with dilute H2SO4 give oxalic acid. Now, what is oxalic acid? Now, one thing about chemistry is ability to actually know what we are talking about. But if I ask some of you now what oxalic acid is, you might not really be able to give me. But I've talked about oxalic acid in previous lecture. Now, when you heat this, it's going to give us COO, Na, and then COO, Na. All right? What happens is you need 2 molecules of this. The hydrogen is removed and then it decomposes. What I mean by this statement, this 2HCOON means you have HCOON and another HCOON A. Right? This hydrogen gas is removed. And when the hydrogen gas is removed, there's a connection here which forms the sodium oxalate. Are you getting it? And then from here, plus of course these 2 that's left here will form hydrogen gas. So we'll have H2 gas. All right, good. So that is that. Now the next one is when calcium formate is heated, it gives formaldehyde. When calcium is heated in the previous case, previous carboxylic acid, we say it will give ketone, but when it comes to formaldehyde, it will give what? Methanol, not ketone in this case. When it comes to formic acid, it will give methanol, not ketone in this case. Other calcium salts, we said, they will usually form ketone, and that is one of the methods we learn for the preparation of ketone. So when this one is heated, it's going to give formamide plus what? Calcium triazocarbonate. All right. And of course, when ammonia is heated, it gives formamide. Everybody know that whenever you are reacting the carboxylic acid with ammonia, it gives the amide. First of all, we said it's going to give us the ammonium salt, which is something like this. Here will be negatively charged, then you have NH4 positive. Why this one will lose water? Was that not what we learned? Exactly. And then this is going to give us this. So you see that it's just for you to understand, when acid reacts with ammonium, it's going to form the ammonium salt first. Then the ammonium salt loses water to form the corresponding amide. Is that okay? So this one will give us plus what? H2O as the byproduct. Alright, so that is that. Now, physical property. Lower carboxylic acid are liquid with sharp odor. Higher members are wax-like solid and almost odorless. Acetic acid is colorless, corrosive liquid with violent odor, sour taste, with boiling point of about 118 degrees, melting point of 16 to 6 degrees. The vapor acid is called glacial acetic acid. Glacial acetic acid is that acetic acid that has lost what? Water. Are you getting it now? It's called glacial acetic acid, the one where they never soak for water, because it forms ice-like solid when cold. It's miscible with water, ether, and ethanol. Boiling point of carboxylic acid are higher than those of alcohol of the same molecular weight.